These notes are for the set of 6.6. In the set of 6.6, you're asked to find, to have the relationship between regular polygons and angles of rotation. So there are two ways that these questions can go. One, they can give you an angle of rotation and ask you to find how many sides. So let's look at that first. How many sides does a regular polygon with an angle of rotation of 15 degrees have? So during the activity for 6.6, you discovered that there's a relationship between the angle of rotation and the number of sides of a regular polygon. So we use this symbol right here, which is the alpha, and it stands for angle of rotation. The 360 is really 360 degrees, and it is the amount of degrees in a full circle. And lastly, the n stands for number of sides in a regular polygon. Remember that this whole idea of regular is really important, and you can't use this formula unless you have a regular polygon. So in this case, they give us an angle degree. So that's our angle of rotation. So we substitute that in. 15 equals 360 over n. I then need to solve for n, so the first thing I'm going to do is get n out of that denominator by multiplying both sides by n. So I have 15n equals 360. To get n alone, I'm now going to need to divide both sides by 15. And so I get n equals 24. So we say the regular polygon with 24 sides has an angle of rotation of 15 degrees. Our second example goes the other way. In this example, we are given the number of sides, but we want to know the angles of rotation. So the question would be, what are the angles of rotation for a regular 9-gon, meaning 9 sides. Again, this word regular is really important. I can't use this formula if I don't know that the polygon is a regular polygon. So again, I'm looking at this lovely formula up here. In this case, they don't give me the angle of rotation, the alpha. They give me the n. So we would say that alpha equals 360 over 9. In this case, it's just a matter of dividing 360 by 9, and that gets me 40 degrees. Now, remember when we were doing these rotations that I actually have to list all the rotations that go up to 360. So we would say a 9-gon has angles of rotation of 40 degrees, and then we keep adding 40 over and over again. So 40 plus 40 is 80, 80 plus 40 is 120, 120 plus 40 is 160, 160 plus 40 is 200, 200 plus 40 is 240, 240 plus 40 is 280, 280 plus 40 is 320, and 320 plus 40 is 360. And we stop at 360 because that is a full circle. So this means if I take my regular 9-gon and I go 40 degrees, I end up on myself. 80 degrees, end up on myself. 120, 160. So I need to list them all because that's how that's all the angles of rotation that end the 9-gon ending up back onto itself.